So, hi everyone. It's my first time speaking to such a big crowd, so keep that in mind. Quick check: who of you creates or uses pixel art in their games? Okay, then you're on the right talk, maybe. All right. About me, who is this guy? I'm Julian, or also Nojoule on social media. And I'm from Germany. And to my background, I have a master's degree in computational visualistics, or for the Germans, computer visualistic. And then I worked 5 years as a software developer, so I have some background in writing shaders and computer graphics, but also writing professional software. And then I decided to become a technical artist. At least that's the terminology that sounded nice to me. And with all the layoffs in the industry, I thought it's the perfect time to join in, right? And like with my games, I always choose the hard mode, so I focus on Godot and pixel art. So that narrows it down quite a lot. But I like it, so let's see if you can learn something from me or get inspired. Oh, and I also like uneven pixel sizes, which sometimes gets me this reaction. But yeah, I do assets like these for 3D. There's like a sky shader for Godot. Here's another perspective with some layered clouds with a specific dithering style that might look aesthetic to some people. But maybe some of you saw my pixel portals, which blew up a bit on social media, at least to my reach. And but in this talk, I focus on my 2D stuff. These are like some shaders I made for applying them to sprites or UI elements. But I go into more detail about these. So the last self-promotion slide is my itch.io, where I put all my assets and the occasional game jam game. So check it out if you're interested. But now to the actual topic, procedural pixel art. I mean, it's a wide range. What does it mean in this context? Or I focus a little bit on my own approach and touching a bit on some general stuff as well. So I set the following scenario. You have a lot of sprites and UI elements, and you want to create one shader that can interact or can be applied to all of these. So you save some work maybe. And yeah, then you have some burning Godot or UI elements. But first, what are our options in general and how does it compare? With hand-drawn pixel art, you have the issues that the workload can add up pretty fast, especially if you hand draw your effects. Think about you have your artist, he made another sprite animation set for a new weapon, and in your game you want to have elemental effects on them, and if you have to hand draw them to interact perfectly with all the weapons, you might have a lot to do. Of course, you can also use some general animations that work with all the weapons, but this is another complexity. Also, changes are expensive in this scenario, so if the weapon shape changes, you might have to redo all your effects. Another approach would be, I'll name it filter or post-processing at the end of your rendering pipeline, that you apply a shader that makes it all pixelated. This might look ugly, but don't get me wrong, I also see some awesome examples out there where it works really good. But in general, it's harder to pull off. And you have limited control, so some effects might not work with this post-processing filter at all, and you have some issues maybe navigating these types of scenarios. So, and you still need to use assets. So if you have some flaming effect, maybe that's not pixel art specific. With the shader, with the filter, it might look like pixel art. But yeah, you still need those initial assets with these filters. But there are also good sides to these approaches. Like with hand-drawn pixel art, if you have a good artist, it might look even better or like perfectly like you imagined. But any game dev that actually produced a game and finished a game knows that perfection is not always the way to go. But yeah, you have also more control with hand-drawn pixel art. So if some weapons or some sprites work a little bit differently, or you imagine the flaming effect, for example, a little bit differently on them, with drawing it by hand, you have much more control. And the positives to the post-processing approach, it saves time. And it's less complicated. It's just at the end of the rendering pipeline. So it's more detached from the whole processes, from the whole process of the assets and so on. And you have a wide range of assets you can use that, gets fixed or gets this pixel art look just by the post-processing filter. It can look more similar, and these are the pros and cons. And where does the procedural approach fit in? I mean, it's all arranged, like the filter, the post-processing filter. I mean, it's can be seen as procedural as well. So my approach is somewhere in the middle. So use hand-drawn sprites and use multiple shaders for different types of effects. So it lies in between. When does it make sense to use? It makes sense if you want pixel art friendly visual effects. What do I mean by that? Let's maybe think about outlines. The outlines, if they should be 1 pixel size, if even 1 pixel fails, the whole outline can break easily. So you have less pixels to work with in pixel art in general. So mistakes are much more punishing, and some visual effects that are more designed for pixel art can help alleviate those issues. Another scenario would be dynamic or reactive visual effects. So with some shaders, you can give in some options for animating stuff, changing a lot of the behavior of these effects, which is much easier than compared to like hand-drawn pixel art effects. And if you don't want to have the cost of heavy shaders to run on your user's device, you can use these shaders in the sprite sheet generation pipeline. So you produce these sprite sheets for all these effects and combinations. And let's think about you have 4 sprite sheets with weapons and attacks, and 4 types of elemental effects. And with these pipelines, you can generate 16 different animations for these different weapons and elements combined. So it saves some work. But you can also just use them as a placeholder or for setting the mood of your prototype, or use these generated sprite sheets as a template for your artist. And bonus points for creating like some procedural shaders. If you are creating multiple games with a similar style, you can reuse parts of the shaders or the full shaders. So now getting more specific into my way, or the sprite was a bit empty, so the highway. But base decisions for my approach, I focused on low resolution pixel art, so it helps a bit with the performance costs. And also with my skills as a pixel artist, with the lower resolution, I can show my demos show them my demos off a bit better. And also limited color palettes. both for performance and for my skills as a pixel artist. And maybe it's the wrong decision, but I want web compatibility also for mobile. So it's the worst case. But let's look at my setup for this. So we have a static image, a subview port where we render the shader for the effect. And most of my effects are iterative. So we use the texture from the subview port from the previous frame and then combine it to have like the full effect. And of course, you can't take just the texture of the subview port in itself, so you copy it. Maybe some eyebrows are rising because this is not really efficient. So we use two subview ports and they use each other's texture. And we alternate between the texture in the rendering result at the end. And we get something that maybe looks like this. But I'll go more into detail on this specific shader. Here we see how the setup looks. For the subview ports, you don't need to have a visual result, but there you can generate some data that you can use with another shader that just visually presents the effect. And here we see the subview ports update each other, and we alternate between which subview port is used for the rendering result. So short summary, two subview ports, then a node that can render in it, and outside a node that you can use to visualize the result. So we have two shaders, one for the data, one for the visual. You can also combine them to use them in both, but then you have a bit more complexity. And yeah, some script to swap the viewport textures, and you can also handle the FPS for the visual effects separately, so the shaders need to run less often for a lot of pixel art effects. I noticed that a lower resolution looks better in some scenarios. So you might want to have some questions or concerns about the efficiency. And you are absolutely correct. So the better approach is to use compositors and compute shaders. But yeah, considering if you want to do some procedural pixel art shaders yourself and don't want to have the mess of handling all the web compatibility and mobile web compatibilities, then go for compositor effects. But yeah, no web builds. All right, but we can do some improvements for my approach. Like I mentioned before, the sprite sheet generation pipeline. So you don't have any issues with either web compatibility or performance costs with a little bit of overhead of making this pipeline. But yeah, you can automate this process. Yeah, another improvement, like I mentioned before, is lowering the FPS. And you can consider having these shaders run on a per instance setup of these subview ports with a lower resolution. Or if you have many instances, you can do the setup once for maybe each effect over the whole camera viewport. Here, some example for me testing the performance. This first one is per instance setup. It blows out of proportion really fast. And here it's just for one viewport, so it works a bit better. But yeah, if you have just a couple instances, it could run fine. But yeah, you definitely have to do some performance testing. So how do you actually create these shaders? For some inspiration, of course, Conway's Game of Life. It's a cellular automaton with some simple rules you can define, which are mostly based on neighboring cells or pixels. And it can create complex patterns. So the potential is definitely there. Another example is the jump flight algorithm. So shout out to Medelaski, sorry for butchering your name. He did an awesome video on how to create this outline shader with Compositor in Godot. So check that out if you want to see some Compositor setup example. But yeah, it's also iterative, uses neighboring pixels mostly, and it splits the process up in creating the data buffer or texture and then rendering the result with the outlines. So now an example of my own, this fire effect. So we can use a color palette to choose in different IDs that are emitting this effect. That's also the pro of the limited color palette, so you can work with it pretty nicely. And we randomize the spawn and decay of these fire effects, and combined with some translation of the UV, so every iteration the previous texture gets moved up a little bit, and then it looks like this dissipating fire. Also for the fire effect you can put in another color palette and iterate through these IDs. Instead of decaying completely, it moves up the color palette until it reaches the end and then it decays. And yeah, so you get something like this. Of course, you can go much more in depth with it and have the flames sway in different directions. So you can do all kinds of things in these shaders. Then the second example is this ice or freezing effect. It grows around the original texture and creates kind of a surface. The growing is based on the distance to the original sprite, so you can put in any kinds of shape. You can also use it on a font. And here I created kind of a 3D feeling with having like a normal map and reflect the light differently in certain conditions. So before I go more into the detail how I created the ice effect, I want to touch upon more of the limitations for using my subview approach. So maybe I should name my talk differently on how to not use focus on web compatibility, but here we go. You need to encode the data in a texture. So we have RGB and A channel, where I marked A as red, because in my experience, maybe I need to look more into detail with it, but in my experience, the alpha can affect the other values when rendering it into the subviewport texture. Maybe I have to look more into detail how it works, but usually I just use the RGB channel and ignore the alpha for now. And yeah, web compatibility is another issue again for mobile, because you usually have less than 3 bytes due to compression of a lot of the mobile web browsers. So watch out for this. And yeah. Now back to our freezing example. So I have 3 channels, and I'll talk about the different channels because I usually, when I create my shaders, I divide it up by different data I need. And firstly, for the freezing effect, we want to grow it outward. So we need to see how much it grows. And here we use like the red channel. Basically, I spawn a full red pixel at any of the pixels that have an non-transparent one in the original sprite sheet. And then we compare it with the neighboring pixels and spread it outward based on some thresholds we calculate of these neighbors. It's a mix of an average and a maximum of these neighboring values, and it results in a shape that it's between a circle or a diamond, so hexagonal maybe. and I feel like it looks nice for an ice. But this is like a trial and error process, which I like to do with my shader effects. And yeah, it's basically the base shape of it. Next, we have the blue channel. Here we calculate the 2D vector pointing outward. How do we do that? We use the red channel we calculated earlier to determine if a pixel is inside or outside the shape. And if we have left, top, right, bottom pixels, and the left and the top are outside the shape, we have a 2D vector that's pointing diagonally to the top left. And from that we can calculate an angle and encode it in the blue channel. And yeah, it's like I mentioned, it depends on the value, the red value we calculated before that. And then we smooth it and spread it inward. So at each of the pixels inside the shape, we basically know where to go to get out of the shape. Then lastly, the green channel. This is basically a measurement for the distance inside the shape to the border. And yeah, the green color spawns at the border and iteratively gets smoothed and spread inward, and it decays a little bit. And yeah, this helps us estimate. So it's not a perfect measurement, but this is like for the visual, not for physics calculations. So we can get away with not having it as precise. And then we can combine these to create the normal map. So then we use the blue channel again, because we now are in a different shader. We have to use the angle and get the 2D vector again. And we use the green channel from earlier to determine the Z portion. So if I go back real fast, we see in the middle the green is getting less. So that means if the green is less dominant, the Z portion gets greater. And at the border, the blue value is more dominant. So we get a nice, nice shape, 3D shape. All right. And then using the normal map, we can use some lighting effects. So we use the light direction or source and combine it with the color palette for the eyes. So brighter values or color points on the surface that are reflecting more light or are brighter in general get a higher color palette ID, and the shadow ones get a lower color ID. And you see these cracks. You may be wondering where they come from. You can also just use any noise textures on it. And this noise texture also influences the color ID. So the cracks are more shiny. And also you can base the transparency on this noise texture. I did it a little bit more complicated, but for the talk it's maybe a bit too much. Maybe you see some greenish stuff in this shape. This is because the noise texture also affects these values. So you can really go overboard with it, and yeah, this also influences the normal map a little bit. So the cracks are also having an effect on the lighting. But yeah, I have many more live demo examples on my itch.io page. So this is focused on UI elements. So you can test it out if it really works on your mobile web browser. I still need to do a lot more testing with it. But I think we have a little bit more time, right? So a bonus slide, 5 tips for writing shaders with mobile web compatibility in mind. First, keep nested if and else statements to a minimum. So the hierarchy of your shaders should be more flat because the web browsers on mobile are not doing a good job of compiling these shaders. So they can even prevent the game from loading at all. And yeah, it's hard to do some pre-compilation for web browsers, so you have to adopt your shader to it. Second, encode the data stable for compression. I marked this red because don't take this as a given. In my experience, 4 bits per channel seem okay and stable. And the third point is limit the size of your uniform arrays. But yeah, for this you can look up specifications. But again, in my experience, 16 vec4 seem okay. This might be relevant if you want to optimize performance by using the color palettes as uniform versus as an input texture. Because with the input texture, you have more texture accesses if you want to determine different states of color palette or the color of your input sprite, for example. So you can navigate this with using uniforms, but yeah, you are a bit limited on that. And that's it. So thank you all for lending me your ear, and I hope I inspired you to some of creating some of these shader effects yourself. And yeah, you can find me on socials or talk to me during the conference. Luckily, with the first talk, a lot of people know me, so I can save some time on explaining what I do. And yeah, it's nice meeting you all in this event, and thank you.